I have to subtract the area of the region covered by the line with the area bounded by the parabola. Mod x is equal to x square, or we can say x is equal to x square. This implies x is equal to plus or minus 1. Since radius is measurement, we should take the positive quantity. So therefore it is 4 root 2 comma 0. Standard form of the equation of root a square minus x square, which can be written as x by 2 root a square minus x square plus a square by 2 sine inverse x by a. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we are going to find the area of the region bounded by the curve and a line. So let us take up the problems now. Find the area bounded by the curve x square is equal to 4y and the line x is equal to 4y minus 2. So clearly I have taken a diagram of x square is equal to 4y, which is an upward parabola, and I have drawn a line x is equal to 4y minus 2. So from the equations here, I have 4y on both the equation. So I can equate them. So we have x square is equal to 4y. So let me take it as equation 1, and x is equal to 4y minus 2. Let me take it as equation 2. So I can equate 1 and 2 because I have 4y as a common factor here. So therefore I can write this as x square is equal to x plus 2. So on solving this, we will get the value of x as x is equal to minus 1 and x is equal to 2. So these are the values of x on solving this. You will get a quadratic equation. Solving this quadratic equation, you will get the values as x is equal to minus 1 and x is equal to 2. So this is what I have taken here, x is equal to minus 1 and x is equal to 2. What will be the value of y at x is equal to 1? So if x is equal to 1, then we have 4y is equal to 1. So therefore y will become 1 by 4. And if x is equal to 2, what is the value of y? Y is equal to 1 because x square is 4, 4 get cancelled, y. So therefore, the curve or the parabola and the line touches at 2 points. One is minus 1 comma 1 by 4, another one is 2 comma 1. Hence, the limits with respect to x are, you are taking only the x coordinate as the limit. So therefore, the limits are from minus 1 to 2 here. So therefore, the required area becomes, required area here is from minus 1 to 2. So the limits are from minus 1 to 2 here. Next, what we need to calculate? We need to calculate the area bounded by the curve. So if I draw a straight line, the area below the straight line denotes the region bounded by the straight line. And if I draw a parabola, so then this will be the area bounded by the region. So what I am supposed to do? I have to subtract the area of the region covered by the line with the area bounded by the parabola. And also both parabola and straight line meets at the same point minus 1 comma 1 by 4 and 2 comma 1. So therefore here what happens? So subtract the line. So here using two equation, we have x is equal to 4y minus 2. So this implies y is equal to x plus 2 by 4. And from this equation we have x square is equal to 4y. So therefore what is y? X square by 4. So I need to subtract these two. So that is x plus 2 by 4. So which is the area below the line minus, and x square by 4 is the equation of parabola in terms of y, and we are integrating this with respect to dx. So now here let me take 1 by 4 as a common factor. So if you take 1 by 4 as a common factor, then the limits are from minus 1 to 2, x plus 2 minus x square dx. Now integrate the following with respect to x. What happens? So this is 1 by 4. So first we have x, which becomes x square by 2, and next we have plus 2, which becomes 2x, and next we have x square, which becomes minus x cube by 3. The limits are from minus 1 to 2. Apply the upper limit as well as the lower limit. So first let us apply the upper limit. So for the upper limit for 2, it is 2 square by 2, 4. 4 by 2 is 2. Plus 2 into 2, 4. Minus 2 cube is 8 by 3. So this is the upper limit. Next we will apply the lower limit. Minus 1 whole square is 1. So it is 1 by 2 minus 2. Minus cube is minus 1. So plus 1 by 3. So on solving this, here we will get the value as 1 by 4. So 5 minus 1 by 2. So solving this, we will get the area as 9 by 8 square units. So this is the area of the region bounded by the parabola x square is equal to 4y and the straight line x is equal to 4y minus 2. So next problem, find the area of the region bounded by the parabola y is equal to x square and y is equal to mod x. So here is a curve which I have taken, y is equal to x square, and this is the function mod x. Clearly the shaded region is the region bounded by the parabola y is equal to x square as well as y is equal to mod x. Now here from the two equations we can see here mod x is equal to x square, or we can say x is equal to x square. This implies x is equal to plus or minus 1, because modulus x can also be taken as plus or minus x, and hence we can get x is equal to plus or minus 1. That means both the curves meet at the points minus 1 and 1 where it is x coordinate. If x is equal to plus or minus 1, then according to y is equal to modulus x, then y is 1. So therefore here we can say y is equal to 1. So therefore the point of intersection are minus 1 comma 1 and 1 comma 1. Also you can see both curves meet at the origin also. Now here we know that the parabola is symmetric towards any axis and modulus function is also clearly symmetric. Here I will calculate only the area in the first quadrant. Then I will double the area so that we will get the total area, because it is exactly the mirror image of this one. So once you calculate the area of this region, then double it, you will get the total area bounded by this region. So therefore the required area becomes here 2 times. Where does the integral? It lies from 0 to 1. Our x coordinate is from 0 to 1. And the first curve is modulus x, we take it as modulus x minus, and the second curve is x square. So x square. So we need to take with respect to dx. Modulus x, I will just write it as x only. So therefore it is 2 times 0 to 1 x minus x square with respect to dx. So next here we have, when you integrate x, you will get x square by 2. And when you will get x square, it is x cube divided by 3. Apply the integral from 0 to 1. So lower limit is 0. So we can leave applying lower limit. Just apply the upper limit. Then you will get 1 by 2 minus 1 by 3, which is 2 into 1 by 6. And when you calculate, it is 1 by 3. So this is the area bounded by the region y is equal to x square and y is equal to mod x. Next, find the smaller area enclosed by the circle x square plus y square is equal to 4 and the line x plus y is equal to 2. So we have two equations here. One is x square plus y square is equal to 4 and another one is x plus y is equal to 2. So here we can write y in the form of 4 minus x square, y in the form of 2 minus x. So clearly we can see this is the circle whose radius is 2. So because it is 4, so it is 2 square. Therefore, the radius of the circle is 2 and both the curves is x plus y is equal to 2. This is a straight line, touches at 2, 0 and 0, 2. So if you take the x coordinate, it starts from 0 to 2. So therefore, I can take the integral from 0 to 2. So therefore, the required area is from 0 to 2. And The first curve is the circle. So it is root of 4 minus x square. And this region is the straight line here. So I have to subtract the region here. So therefore it is minus of 2 minus x with respect to dx. Now I need to integrate it and apply the definite integral here. Now the first one is a standard form of the equation of root a square minus x square, which can be written as x by 2 root a square minus x square plus a square by 2 sine inverse x by a. So in the place of x you have x only, in the place of a you have 2. So therefore this I can write it as x by 2 root of 4 minus x square plus a square is 4 by 2 sine inverse x by 2. X by a becomes x by 2 here, and here minus. What is integral of 2? It is 2x. Again minus into minus plus. What is integral of x? It is x square divided by 2. Apply the integral from 0 to 2. Since the lower limit is 0, we can neglect it. Just apply the upper limit. Now if you put 2 in the place of x, clearly you see the first term becomes 0, because here x square becomes 2 square, 4 minus 4 0, root 0 is 0, 0 into anything is 0. The second one can be written as 4 by 2 can be written as 2. Here in the place of x if you put, it becomes sine inverse 1. So therefore you can write it as 0 plus 2 into sine inverse 1. Next you have minus 2x, which becomes 2, which is minus 2 2s are 4. Next you have 2 square by 2, which is 4 by 2, so plus 2. So now this is 2 into, what is sine inverse 1? Pi by 2, minus 4 plus 2. So 2 get cancels, it is pi minus 2 square units. So this is the area bounded by the circle x square plus y square is equal to 4 and the line x plus y is equal to 2. Next, find the area of the region in the first quadrant enclosed by the x-axis and the line y is equal to x and the circle x square plus y square is equal to 32. So if you put y is equal to in this equation, then it is x square plus x square is equal to 32. I'll get x square is equal to 16. This implies x is equal to plus or minus 4. And this also implies if x is equal to 4, y is also 4. If x is minus 4, y is also 4. So that means both the circle and the line meet at the point 4, 4 and minus 4, minus 4. So these are the point of intersection, but here they have asked you to find the region only in the first quadrant. That means our region starts from 0 to, so till here. So what is this point? This point is 4 root 2, 0. Why? Because the radius of the circle here r square is equal to 32. So therefore r is equal to 4 root 2. Since radius is measurement, we should take the positive quantity. So therefore it is 4 root 2, 0. Now here I have divided the portion into two parts. So this is my first part and this is my second part. So if you add both the regions, then you will get the region bounded by the circle as well as the straight line. So that is why, so here I will take required area is equal to area of triangle, that is OMB. Okay, we can take it as triangle OMB plus area of region. What is this region? I can take it as MBAM. MBAM. So this is the second region I am taking. That means the required area is the sum of the triangle as well as the region MBAM. Now we can apply the limits. So here for the first triangle, see it is, the limits are from 0 to 4. So only this region is the part of triangle. Can be also written as half into base into height. Because this is the base, OM is the base whose distance is 4 and BM is the height of the triangle whose distance is 4. So half into base into height, and here the area of this region starts from, so what is this point? This point is 4. So it is 4 to 4 root 2. So therefore here it becomes 4 to 4 root 2, and this is the area bounded by the circle, and hence we will take this circle, that is square root of 32 minus x square into dx. So this is the total area bounded by the region, circle and the line in the first quadrant. This can be written as 8, and here this becomes x by 2 root of 32 minus x square plus a square is 32 here. So therefore it is 32 by 2 sine inverse x. So sine inverse x divided by a. What is the value of a? That is, a can be taken as radius, which is 4 root 2. So 4 root 2. So and apply the limits from 4 to 4 root 2 here. So then it becomes 8 plus, apply the limits for this function from 4 to 4 root 2. So the first one here is, if you put here 4 root 2, then the first term becomes 0. So the second term is here 32 by 2, which becomes 16 sine inverse 1. Because when you put 4 root 2, 4 root 2, 4 root 2 cancel. So therefore it becomes 1. Next we have minus lower limit. So what is the lower limit we have? Substitute x as 4 here. So 4 by 2 becomes 2. Next is root 32 minus 16. 32 minus 16 is again 16. So which is root 16. Plus 32 by 2 is again 16. And here if you put 4, 4 get cancelled, it is 1 by root 2 whose value is pi by 4, or we can write it as sine inverse of 1 by root 2. Now here we have 8 plus 16 pi by 2. Next we have minus 2 root 16 minus root 16 can be taken as 4. So it is 8. Next we have plus into minus, minus 16 into pi by 4. So here plus 8 minus 8 can be cancelled. So we have 16 pi by 2 minus pi by 4, which becomes pi by 4. 4 ones are 4 fours are. So 4 pi square units. So this is the required area bounded by the region. Next question. Find the area of the region bounded by the parabola y is equal to x square and y is equal to x. So previously we have taken y is equal to modulus x. Therefore, we have both the straight line along the first quadrant as well as the second quadrant. But this is a straight line passing only through origin. Hence, we have the area. Clearly, you can see we have from the equation we can take x is equal to x square. So this implies x is equal to 1, which implies y is equal to 1. That means both the curves meet at the point 0, 0 as well as 1, 1. And therefore here required area is integral from 0 to 1. So the straight line is x and the curve is x square dx. Now apply the limits for this function. It is x square by 2 minus x cube by 3 from 0 to 1. So if you apply the limit, then it is 1 by 2 minus 1 by 3 whose value is 1 by 6. So this is the area bounded by the region y is equal to x square and the straight line y is equal to x. So until here we have learned the area bounded by the curve and the line. In the next session we are going to learn about the area between two curves. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.